SVM जैसे हम लोग को अभी पता है कि like it's nothing but a classifier and it is nothing but a linear classifier. Okay, और उसका actually कामकाज क्या है? What is the use of the SVM? It is just used to using SVM. We will just use to just draw a line to just separate two classes. That's that. उसमें सिर्फ हम एक सिंगल लाइन ड्रॉ करेंगे दो क्लासेस को, like otherwise more than one classes are also there, but consider there are two classes right now. So बाइनरी क्लासिफायर का एग्जांपल लेते हैं, एक लाइन ड्रॉ करके हम दोनों को सेपरेट करेंगे. So now उसमें सबसे पहली चीज हमारे पास ऐसा था कि हम एक स्टैंडर्ड पोजीशन पे चले थे कि हमारे पास ऐसा डेटा सेट है जो लीनियरली सेपरेटेबल, जिनको हम लोग एक्चुअली एक लाइन से दो पार्ट में डिवाइड कर सकते हैं. दैट्स द थिंग, हम लोग उनको दो पार्ट में डिवाइड कर सकते हैं. दैट्स द थिंग. ओके, बट नाउ अनदर ऑप्शन इज कंसीडर हमारे पास एक पहला ऑप्शन था कि लीनियरली क्लासिफाइड डेटा. सेकंड हो सकता है कि हमारे पास नॉन लीनियर डेटा सेट. नॉन लीनियर डेटा सेट इन द सेंस व्हाट? In the meaning of non-linear data set is actually linear with some noise, and another thing is actually non-linear. Actually non-linear in the sense that it's not possible to just draw a line to separate them. So in both these cases, हम लोग normal एक line directly draw करके उनको separate नहीं कर सकते. Then we have two solutions. The first option is actually soft margin. We can just go with soft margin. Otherwise, we have to just use a kernel trick. So now, what is soft margin and what is kernel? Soft margin in the sense what? We learned this thing in last session, not in last, but last session. What is soft margin? Soft margin in the sense what? We have to ignore something. We have to ignore some values. Otherwise, we have to just we have to allow some guys to be plotted in opposite direction or in opposite class. मतलब जो हमने margin वाला line draw किया था, like consider हमारे पास दो classes थे. The first class is nothing but a cross. Another class is nothing but a rectangle. तो हम लोग दूसरे डायरेक्शन में भी अलाउ करेंगे कि क्रॉस वाला बंदा रेक्टेंगल की पोजीशन पे भी हो, तो एक लेवल तक हम उसको अलाउ करना है. सो दैट्स नथिंग बट इन सॉफ्ट मार्जिन. नाउ व्हाट अबाउट कर्नल ट्रिक? व्हाट अबाउट कर्नल ट्रिक? Another option is the kernel trick is nothing but like whenever you have a data, like whenever you have a non-linearly separable data, like 1 minute, yeah, fine. So that is actually two-dimensional space hyperlink. That is actually linearly separable data. हम लोगों ने normal एक line draw करके उसको linearly separate कर. But now consider in some cases we have a data set जो actually linearly separable नहीं है. So here this is the non-linearly separable. In short, non-separable cases actually. That is linear but non-separable cases. So what we have to do? We have to just allow these guys. हम लोग को इनको allow करना पड़ेगा. So like ये opposite direction या दूसरे classes के अंदर भी हमारे कोई data available हो. So that is actually known as soft margin. That is the first thing. That is actually known as soft margin. That's the first solution and this first option to work with that. Second one is actually kernel trick. So what is kernel trick? Kernel trick in the sense what? Firstly, we will actually we will just like transfer our feature data, otherwise our data into some another space. Ensure two-dimensional, and then we will just create a three-dimensional data set. Like a three-dimensional, and then we will just create a four-dimensional data set. So in short, that's nothing but an actually transfer your data set into some another data space. Okay, like मेरे पास 1D data set था. So here we have an example of 1D actually. Not here actually. 1 minute. Yeah, fine. So this is the one-dimensional data set. In short, it's nothing but a horizontal row. That's nothing but a horizontal row. So we cannot actually divide this one by just drawing a single line. We have to just draw the two lines actually. So that is not an SVM. So what we have to do, we have to just convert this data set into two-dimensional. तो ये 1D डेटा सेट था. 1D इसलिए बोल रहा हूँ बिकॉज मेरे पास एक हॉरिजॉन्टल लाइन थी, उसको टू डायमेंशनल में हमने कन्वर्ट किया. Now guys, easily we can just draw the normal SVM or normal actually line to just separate this data set. So that's the thing. So हम लोग अब क्या कामकाज करने वाले हैं, हम हमारे डेटा सेट को हम ट्रांसफर करेंगे. And for that that thing is actually known as now if you want to just transfer your data set into some another dimension, then guys, what is our requirement? We required actually some function for the mapping. Okay, for the mapping purpose we required some function actually. So let me continue with our original like presentation. So fine. Yeah, fine. So that is the thing. So that's nothing but an actually data set with actually like that's a data set which is not actually separable actually. So what we have to do, that's a one-dimensional data set. So what we can do, we can just divide that one into two-dimensional. But what we have to do, अगर one dimensional को two dimensional में convert करना है, then guys हमारे पास one dimensional में सिर्फ क्या coordinate होंगे? Only x coordinates will be there. But two dimensional में then we must have x and y coordinates. Then x coordinate को x and y coordinates में कैसे map करें? What will be the function? So for that we require some function. So here this is the function. This is the function. Now how to like consider this function? Just ignore that. वो हम लोग बाद में देखते हैं, but just ignore that right now. So we require some mapping function. So consider that mapping function is z, or you can consider that mapping function is phi. What is the use of this phi, or what is the use of this z? It is just used to map the n dimensional to n plus 1 dimension. Even though अगर आप n dimensional को n plus 2 dimension में map करना चाहते हैं, that's up to you. But it is just used to like map the lower dimension to higher dimension. That's the thing. It is just used to map the lower dimension to higher dimension. That is the thing. That's pretty simple. Okay, now here we have, like, consider this is I have data set. This is my data set. Now it is not a linearly separable. So what I am doing, I will just map this two-dimensional to three-dimensional. I will just map this two-dimensional data set to three-dimensional by just applying, otherwise by just using this mapping function. And this mapping function is nothing but a phi. So now what will be the logic? What is the actual logic of this phi? Otherwise, what is the relationship between the two-dimensional or three-dimensional? Just ignore that. That's not an important thing. But now consider this is the function which is just used to map the 2D to 3D in this case. Now after just mapping this 2D to 3D, it is linearly separable. So we can apply our normal SVM rules over there. So now we just go through the example also. हमारे पास two-dimensional कुछ था, उसको three-dimensional में convert किया था. And after that हमने एक hyperplane वहाँ पे plot किया था. So it was actually easily separable. So now guys, this is actually a phi. This is actually a phi of x actually. So now what's the phi of x? So what we did is just ignore this under root 2. Just ignore the square root of 2. Just ignore that. Now what we have, that is actually linear terms. Okay, this is nothing but in constants. Just ignore that also. So this is the linear term. These are nothing but in quadratic term. Quadratic term in the sense square term. Okay, तो यहाँ से यहाँ तक सब के सब squares है. आप देख सकते हो कि हम लोगों ने a square, b square, मतलब like a1 square, a2 square, a3 square. What is that a? It's nothing but an actually like you can say that it's a features. And what about this one? यहाँ पे भी once again आप देखें तो a1 into a2, a1 into a3. In short, a1 into and मतलब there are two loops actually. Nested loop is there. So outer loop अगर 1 से m तक जा रहा है तो inner loop will start with actually j equal to i plus 1. मतलब अगर i का वैल्यू 1 है तो j का वैल्यू कहां से स्टार्ट होगा? j will start with 2 and 2 से लेके m तक. मतलब ये किस तरीके से मल्टीप्लिकेशन होगा? a1 a2 a1 a3 a1 a4 a1 m. नाउ a2 से स्टार्ट करेंगे तो a2 a3 a2 a3 then a2 a4 a2 a5 and then a2 to m. In a similar way it will works. Okay, so am minus 1 to am, that's the last one. Am minus 1 to am, that is the thing. So this will be the multiplication. And हर एक के आगे under root of 2 क्यों लिखा? That's nothing but a constant value जो हमारा task easy करके दे. That's not important, but this is the concept. This is the function actually. But now if someone say, okay, I have only two terms, x1 and x2, then I have only two features actually, x1 and x2. Then what do I have to do? Then guys, under root of 2 अगर एक बार ignore भी करे, under root of 2 एक बार ignore भी करे, तो यहाँ पे पहले x1 then x2. That's that. x1 and x2. Then what we require? Actually, we require x1 square plus x2 square, and according to this function, x1 into x2 plus 1. That will be the phi. अब ये कहाँ से आया? ये पूरा का पूरा फंक्शन कहाँ से? We have not to worry about that because actually देखें तो ये पूरा फंक्शन हमारे पास यहाँ से कुछ आया हुआ है. Just a moment. मैं थोड़ा previous slide पे चल रहा हूँ. That is actually optimization problem और हमारे पास primal and dual ऐसे दो problems थे. And we just accept one thing that this is the primal problem. What is the primal problem actually? The primal problem is now we have this equation. And yeah, fine. This is the thing we require. We want to maximize this margin value. मैं equation पे नहीं जा रहा. We want to just maximize this margin value. So what we have to do? We have to just minimize this. Okay, and sorry, we have to just minimize this under root of w into w. हम लोग को इसको minimize करना पड़ेगा. And these are the constraints. This condition must be satisfied. And अगर ये condition के हिसाब से work कर रहा है, then easily we can classify our points either above of the SVM or below the SPM. Okay, so for that इस equation में हम लोग को ऐसा करना था कि okay, minimize this w into w. अगर इसको minimize करेंगे the margin will be maximum, and these are nothing but in constraints. In short, this must be met. So now finally, like phi of w, that means what? This must be minimized. This thing must be minimized. अगर ये minimized हुआ, then our task will be done. And यहाँ पे हमने एक general formula लिखा था yi in the bracket wt of xi plus b greater than or equals to 1. So that's the thing. Now this is the primal problem, and if you want to optimize this problem, if you want to just optimize this problem, then guys, it is hard to optimize this quadratic problem. Why that's quadratic? Because यहाँ पे actually transpose और original का multiplication है, so it will be the quadratic equation. Okay, वो quadratic equation बनेगा. So what we did, हम लोगों ने यहीं पे जो multiplication का term था, हम लोगों ने multiplication term as it is रखा, and by using some optimization theorem, okay, we just accept that thing. We didn't calculate or we didn't actually derive that formula. But what is that? We just introduce some actually like constants. In that phi example, the constant is under root of 2. Okay, we can calculate that also, but just ignore that. But right now we just introduce them constants. Just consider that's actually alpha of I, alpha j. These are the constants. What about the yi and yj? These are nothing but class value. Class value in the sense, in this example, we consider we have only two class values, that is actually 1 and -1. Only two class labels are there. So this is nothing but in class value. And what about this xi and xj? These are nothing but in feature value. Okay, these are the feature value of ith row and jth row. Sorry, ith feature value and jth feature value. So that is the multiplication. Now what about the sigma? Please do the summation of them and just apply this formula. So that's nothing but in like using this function, you can just derive this phi value. Okay, using that you can just derive that phi value. I hope that is clear. So how to find out that value? So that's actually primal to optimization जब theorem apply करेंगे then it's a dual problem, and in this way we can just calculate this phi value. But right now for this session, just consider that is the phi value. Now what is the requirement? We have to apply this phi value to just convert our 1D to 2D or 2D to 3D, 3D to 4D and something like that. Okay, so now हम लोग को हमारे feature values इसमें input करने हैं, and we will get actually new feature value. Just consider what about this x? That is our feature value. So we have to apply this function. We have to apply this function. You will get actually higher dimension value. तो आपको जैसे आपने one dimensional values put की x की, let I consider I have a two dimensional. Okay, मैं two dimension पे work कर रहा हूँ and I have a actually feature value of 2,3. That is nothing but in coordinate. Just consider. तो मैं 2,3 पुट करूंगा and I will get actually 2,3,1. Just consider मुझे 3 dimensional value मिलेगा by applying this function. I hope ये आपको समझ में आया. और अगर मान लो मैं स्क्वायर फंक्शन अप्लाई कर रहा हूँ, स्क्वायर इन द सेंस में क्वाड्रेटिक अप्लाई कर रहा हूँ, कि मैं 2D को 4D में कन्वर्ट कर रहा हूँ. सो 2D जब मैं इनपुट करूंगा तो मुझे 4 डायमेंशनल वैल्यू मिलेगी. 2D अगर मैं इनपुट करूंगा तो 4 डायमेंशनल वैल्यू मिलेगी. सो गाइस, like whatever the dimension value you have, अब जो भी इनपुट करोगे उससे एक्चुअली आपको लार्जर मैट्रिक्स या लार्जर आपको डेटा सेट मिलने वाला है. Why I'm talking about the matrix? Because we will have actually number of rows and number of columns. So the first problem is how to store this matrix. That is the biggest task. And finally, we have to just apply the multiplication actually. जो हमारा actually final answer आ रहा है, like that is the thing. जैसे हम लोग x और y input करेंगे, what is that y? It's nothing but a labeled value. What about the x? It's nothing but a feature value. तो जब आप उसको ट्रांसफर करेंगे, जैसे कि मैं इस डेटा को ट्रांसफर करना चाहता हूँ, ट्रांसफॉर्म फ्रॉम x to like x of phi of x and transform from y to phi of y. So इनका जो भी आंसर आ रहा है, what we have to do finally, we have to just perform the multiplication or dot product on that, because our equation says we have to just apply the dot product actually. Okay, dot product to apply करना ही पड़ेगा. Why? Because we want to just find out the best value for w and best value for b to just maximize the margin. So हम लोग multiplication का anyhow हम लोग को apply करना ही. So now that is hard thing कि हम लोग एक तो dimension change करें, तो ये मुझे higher dimension data मिल रहा है, then we have to store with higher dimension data. Now वो higher dimension जो भी data मिला था, उन data का मुझे multiplication करना है. Once again we require a like large computational task, like high computational time we required. So it is a time consuming process, guys. So is there any shortcut? Yes, there is a shortcut. And what is the shortcut? The shortcut is nothing but a kernel trick. What is that kernel? It's also a function. What is that kernel? It is also a function. You can say that f, you can say that k, you can say that d. It's nothing but a symbol to represent the function. Now what we have to do, just pass your original data set. Do not transfer the data set. Do not transfer the data. Do not perform this step. Just transfer the original data to just pass original data set to k. What is that k? It's a kernel function. So now how to choose this kernel function, we will learn that in a few minutes. We will just discuss that also, but now just pass the original data set to this K, and so like actually we want to find out this thing. हम लोग को ये चीज चाहिए थी. Why we want to just find out this? Because we have a data set which is actually not linearly separable. So to just like make it linearly separable, we are just transforming the 2D data to 3D data set, or 3D to 4D and something like that. And for that we have to just we have to choose some proper phi function. We have to transfer the data from n dimensional to otherwise lower dimension to higher dimension, and then we have to just apply the dot product. So finally, this is our requirement. This must be met. This is our requirement. But now what we did, हम लोगों ने क्या choose किया, guys? We choose one thing like please do not transfer the data set. हम लोगों ने ऐसा कुछ किया हो, please do not transfer the data set. Let's pass the original data set to this K function and just find out the value. But guys, like this is kernel trick in the sense what? It's a magic. Here, whenever you will just apply this function, you will get the equivalent answer of this phi x into phi y. In short, ये जो आपको multiplication मिलने वाला था, और आप अगर k वाला function apply करोगे original data set के ऊपर, still you will get the same answer. Now, what is that k? K is nothing but a kernel matrix. K is nothing but a kernel matrix. That's it. Okay, so now what is what will be the dimension of this matrix? So what it does, K is known as kernel matrix, captures the similarity between the training instance X and Y. It just captures the similarity between training instances X and Y. So if there are large similarity, if there is a huge similarity between the training instances, then the matrix size will be larger. If there is a lesser similarity, then the matrix size will be smaller. Okay, now that's that. So now let me just move to the backward. Ek slide back jate. So actually this is the actual, yeah, fine. So this is the actual equation. This is our task. ये हम लोग करना चाहते हैं. Here one actually that's actually select variable. Okay, it must be greater than equals to 0. ये condition यहाँ से कट हो चुकी है. Okay, ये हम लोग को ऐसा कुछ कामकाज करना था. Why I just add this? Because of the soft margin. Okay, and this must be the constraint that must be made. So this thing I required. So now guys, this is the primal problem and this is the dual problem. Once again, ये हम लोग एक बार once discuss कर चुके. So here we required actually dot product dot product in between actually features. Okay, so using optimization theorem, we just convert the primal to dual. Now training examples only occurs at the dot products. Just consider these are the training values, these are the feature values. और वो मुझे कब मिलेगी? It occurs only the dot products of each other, not individually. And you can consider like यहाँ पे ऐसा लिखा हुआ है x of k dot x of l. Okay, in short, I mean to say कि वो features का multiplication हो रहा है, nothing else. उससे features का multiplication हो रहा है. In short, we require a dot product. This term we will that term actually we require in future also. Okay, इसके ऊपर mainly focus करना है because alpha are the constants. What about y and yk and yl? These are nothing but a labeled value. So just ignore that also. So we will not discuss this thing actually. So finally अभी मुझे क्या करना था, अब इन्होंने स्लाइड में तो ऐसा कुछ बताया कि सर phi x into phi y अगर आप करते हैं and अगर आप कर्नल ट्रिक अप्लाई करते हैं, then you will get the same answer guys. आपको दोनों का आंसर सेम ही मिलेगा. So let me check. So now what I am doing, consider I have x and y, otherwise I have two values a and b, and I want to apply phi a multiplied by phi b. So what is the value of phi? So हम लोगों ने थोड़ी देर पहले ये वैल्यू को चेक किया था. So that is the value of phi. So let I just apply phi a and phi b, and let me just find out the dot product in between them. So now what will happen? 1 into 1, that will be 1. 1 into 1, that will be 1. And now up to this, यहाँ से यहाँ तक जो टर्म है उनका अगर हम मल्टीप्लिकेशन अप्लाई करें तो हर एक जगह पे हमारे पास अंडर रूट ऑफ 2 है. Under root of 2 into under root of 2, that's actually 2, and a1 into b1, a2 into b2, a3 into a3, and that is actually known as I1 to m. What is that? M is number of features. M is nothing but a number of features. So I equals to 1 to m in the bracket, like it's a summation from I equals to 1 to m, 2 into a of I, b of I. Now let me just consider all this one. तो यहाँ से यहाँ तक का हम लोग पार्ट कंसीडर करें तो a1 square b1 square and something like that, so I equals to 1 to m a1 square b1 square. And now अगर guys इनका multiplication करें, so what will be the answer? Under root of 2 into under root of 2, that will be 2. And now a1 a2 b1 b2, so that means ai bi and aj bj. Sorry, ai aj bi bj, something like that. Otherwise you can say that ai bi aj bj, and I will start from 1 to m and j will start with I plus 1 to m. That's it. So that is the multiplication. So अगर मैं phi a multiplied by phi b करूं, so मुझे ऐसा कुछ आंसर मिलने वाला है, मुझे ऐसा कुछ आंसर मिलने वाला है. Now let me just apply some kernel. So randomly let me just choose a kernel function, and my kernel function is actually ab plus a plus 1 whole square, a into b plus 1 whole square. Now like as we know, ये कुछ 7th या 8th standard में formula learn कर चुके थे, x plus y whole square that can be expanded into x square plus 2xy plus y square. For the first term का square plus 2 into first term into second term plus second term square. So let me just apply the expansor rule. So ab square plus 2ab plus b square. Now what about that a and b? That's actually x and y you can consider, but a and b के अंदर actually like features होंगे, feature value will be there. So a के अंदर कुछ features value होगा, b के अंदर कुछ feature value होगा. So let me just apply sigma of I equals to 1 to m ai bi whole square. In a similar way we can apply the sigma over here also, because that's actually a multiplication, but a and b are actually a universal value, or you can say that it's nothing but an like feature set actually. So now consider you have m number of features, so like this multiplication also can be written as actually 2 into sigma of I equals to 1 into ai bi plus 1. Now up to this I hope आपको कोई problem नहीं है. Now guys I have actually ai and bi whole square, so that is actually loop. So consider like it's a square, so I can just write down the square into two different loop, but in a nested loop I can just write down. So I just write down sigma of I equals to 1 to m, sigma of j equal to 1 to m, and ai bi aj bj, nothing else. Okay, fine. So this is I can just write down this equation like this. But now I want to just like prove that k of xy is nothing but an phi of x into phi of y. I want to just prove this thing. The kernel of x of y is equals to phi of x into phi of y. And what is phi of x and phi of y? Consider this. Here we are just using a and b in the place of x and y. So phi of a into phi of b is nothing but a summation of all these things. It is nothing but a summation of all these things. So answer must be actually 1 plus sigma of I equals to 1 to m2 of ai bi. So here we have that thing. ये चीज हमारे पास मिल चुकी है. Now sigma of I equals to 1 like ai square bi square. Then sigma of I equals to 1 j equal to I plus 1 to m 2 into ai bi and aj bj. So now this term is not actually, we cannot get this term actually. So now guys just consider, I just told you one thing. Here we have actually a matrix. Okay, after transferring the data we will have actually a matrix. And what about this ai and bi? What about this ai and bi? So ai and bi is nothing but a trade of this matrix, or you can say that it's nothing but a diagonal of this matrix. Consider I equals to 1 j equals to 1, that's the first term. I equals to 2 j equals to 10 j equals to 2, that will be the second term of this diagonal, and etc thing. So now मैं इनका अगर मल्टीप्लिकेशन करके स्क्वायर अलग से लिखूं then it's fine. हम लोग ये लिख सकते हैं कि हाँ भाई मुझे पूरे मैट्रिक्स का ये टर्म को देखिए, ये टर्म्स को देखिए, हम लोग यहाँ पे पूरे मैट्रिक्स के सभी एलिमेंट्स का मल्टीप्लिकेशन कर रहे हैं. सो व्हाट आई एम डूइंग, मैं इसमें से सिर्फ ये वाला एलिमेंट कंसीडर कर रहा हूँ, मैट्रिक्स का एक डायगोनल कंसीडर कर रहा हूँ. नाउ डायगोनल के ऊपर मेरे पास कुछ पार्ट है, डायगोनल के लाइक बॉटम में मेरे पास कुछ पार्ट है. नाउ गाइस लेट अस जस्ट once again draw this thing. Yeah, fine. So now consider this is the matrix. Okay, and अगर मैं आपको ऐसा बोलूं ओके मुझे अब रो एंड कॉलम सभी का मल्टीप्लिकेशन करके उनका स्क्वायर करके दीजिए, तो आप क्या करेंगे, लाइक हर एक टर्म का मल्टीप्लिकेशन करना है. सो ai into bi, so that is ai in the sense पहले फर्स्ट रो and bi in the sense आपको पूरे सबके सब कॉलम्स लेने. So you will just apply the loop inside the loop. You will use loop inside the loop. Now second रो पे आके वापस सबके सब कॉलम्स, थर्ड रो पे आपके सबके सब कॉलम, उनका मल्टीप्लिकेशन करना है. Finally I required the summation of them. Now उसी चीज को मैं ऐसे लिखूं, okay now I have actually diagonal summation. मुझे पहले डायगोनल का मल्टीप्लिकेशन करना है. सो डायगोनल इन द सेंस i and j मस्ट एक्चुअली उनकी वैल्यू सेम होनी चाहिए, i और j की वैल्यू सेम होनी चाहिए. तो मैं इसके लिए ऐसा लिख सकता हूँ लाइक सिग्मा ऑफ ai bi sigma of sorry ai into bi plus bi in the sense b वाले में वही कॉलम चूज करना है जो रो है. इन शॉर्ट आई वांट टू जस्ट अप्लाई द मल्टीप्लिकेशन ऑफ द डायगोनल वैल्यूज. गाइस समझ में आ रहा है विजय सर? लाइक पृथ्वी समझ में आ रहा है? मैं इस टर्म को एक्सपांड कर रहा हूँ, ये जो टर्म लिखा है उसको मैं एक्सपांड कर रहा हूँ.
यस
ओके फाइन. सो मैंने सिर्फ डायगोनल की वैल्यू ली. डायगोनल मतलब यहाँ पहली वैल्यू होगी 1 1 2 2 3 3 4 4 5 5 6 6 7 7 एटसेट्रा. तो अगर मुझे सिर्फ डायगोनल की वैल्यू लिखनी है तो मैं ये टर्म लिख सकता हूँ, सिग्मा आई इक्वल्स टू 1 ai bi होल स्क्वायर. स्क्वायर क्यों कर रहे हैं? बिकॉज मुझे 2 टाइम्स चाहिए था. स्क्वायर क्यों कर रहे हैं? स्टिल इग्नोर दैट. ओके सो ai bi क्यों लिखा? आई होप ये समझ में आया. नाउ अनदर थिंग इज, अगर मैं डायगोनल के ऊपर वाली वैल्यू कंसीडर करने की ट्राई करूं, डायगोनल के ऊपर की वैल्यू कंसीडर करूं, दैट मींस व्हाट? मेरा i का वैल्यू अगर 1 है देन j मस्ट स्टार्ट विद 2 एंड 2 से लेके m तक. जब i का वैल्यू सेकंड रो में 2 होगा then j must start with actually 3 to m in short last column. so उनका मुझे मल्टीप्लिकेशन करना है. एंड यहाँ ये जो बॉटम वैल्यू है, डायगोनल की बॉटम जो वैल्यू है, इट्स नथिंग बट अ शैडो ऑफ द अपर वैल्यू, बिकॉज हम लोग ट्रांसपोज के साथ वर्क कर रहे हैं. सो दैट्स नथिंग बट अ शैडो वैल्यू. तो मुझे क्या करना है, इसका जो आंसर आ रहा है उसके साथ इसका एडिशन करना, बिकॉज बोथ हैविंग द सेम वैल्यू. so that I can just write down the same equation into this way, like sigma of i equals to 1 to m, that means all rows, and j equal to I plus 1 to m, because मैंने like the next column, like diagonal already I considered, so j equals to I plus 1 to m, ai bi aj bj, and उसको 2 क्यों लिख दिया? because upper value, upper diagonal value will be same as a lower diagonal value. So now guys, this term can be expanded into this part. So now you can just like you just observe one thing, कि हम लोग phi a into phi b जो करते थे, इसकी जगह अगर हम कोई कर्नल फंक्शन चूज करें, so that will be answer will be the similar. Okay, but now the best thing of this kernel function is that is actually we have to just perform like big O m notation. What is that m? That's actually complexity. So whenever you will just perform this task, this is the actually requirement, big O m. M in the sense what? That is actually number of features. Okay, only number of features. जितने मान लो आपको बोलूं मैं 10 number of features I have, then you have to apply the operation for 10 times only, because हम dimension change नहीं कर रहे. ओके बट अगर आप 5 फंक्शन में कन्वर्ट करोगे, देन गाइस अगर मान लो मैंने m को स्क्वायर वाला फंक्शन अप्लाई किया, so if you have 10 elements otherwise 10 features, then after applying that 5 function you will have actually 100 features because मैं dimension extra कर रहा हूँ. then अगर मैं कोई फंक्शन otherwise multiplication अप्लाई करूँ, then I have to apply the multiplication over 100 by 100, and यहाँ पे अगर हम लोग वर्क करते हैं then 10 by 10. So that is the computational task बहुत decrease होगा. So that is the thing, higher order polynomials. ये लिंक ऑलरेडी हम देख चुके हैं. मैंने लास्ट सेशन में आपको वो 3D विजुअलाइजेशन वाला एक YouTube बताया था. Now guys, we have a polynomial, so maybe you have actually quadratic polynomial, cubic polynomial or quadratic polynomial. So now अगर आप quadratic polynomial apply कर रहे हैं, then all m square in the sense what? M means what? That's number of features. So now m square by 2 terms up to degree 2. हर एक terms का actually हम लोग को square करना है. Here we have to apply m cube. Here we have to apply m raised to 4. So now what will be the actually sorry cost to apply this function? Transfer करने के लिए जो हम लोग को cost apply करना है, what will be that? So actually this r is nothing but a number of rows, and m square are nothing but m is nothing but a number of features. So m square into r square divided by 4, that will be the cost. Here m cube r square divided by 4 divided by 12, that will be the cost. And this will be the cost actually required to just convert your data by applying a particular phi function. तो quadratic apply कर सकते हो, cubic apply कर सकते हो, quadratic apply कर सकते हो. And what will be the cost if 100 inputs are there? So guys, m की value में 100 put कर रहा हूँ. 100 inputs in the sense consider that's nothing but a feature value. So you have to just this is the cost value actually 2500 r मतलब number of rows. This is the cost value. And अगर मैं इसकी जगह कोई कर्नल फंक्शन, this is my k actually, इसकी जगह मैं कोई कर्नल फंक्शन लूँ तो एक्चुअली क्वाड्रेटिक के लिए एक्चुअली मेरे पास कर्नल फंक्शन है a b plus 1 स्क्वायर, यहाँ पे क्यूब, यहाँ पे रेज़ टू 4 एंड एटसेट्रा थिंग. सो ये पॉलिनोमियल है. तो फिर हायर ऑर्डर पॉलिनोमियल्स. सो आप देख सकते हो जैसे मेरा यहाँ पे क्वाड्रेटिक, क्यूबिक वगैरह वगैरह चेंज हो रहा है, तो यहाँ पे स्क्वायर की जगह क्यूब, क्यूब की जगह रेज़ टू 4 एंड समथिंग लाइक दैट. And here I do not want to change the m. M will be original. So what will be my cost? जैसे यहाँ पे m square cost था, here it will be actually m r square by 2. here actually m r square by 2, here also it actually m r square by 2, because मैं actually m की वैल्यू m ही रख रहा हूँ, मैं उसको चेंज ही नहीं कर रहा. So m की वैल्यू m इन द सेंस में डायमेंशन चेंज ही नहीं कर रहा. और अगर मान लो मेरे पास 100 इनपुट है तो m की वैल्यू 100 रखे तो 100 डिवाइड बाय 2 that will be 50. So 50 r square that will be the cost value actually. 50 r square that's the cost value. So quadratic ho ya cubic ho, it doesn't matter, dimension doesn't matter if you are applying the kernel function. Okay, so these are some kernel functions. So guys, you can just apply the polynomial kernels. Polynomial kernels in the sense what? In a previous slide we just discussed that. Okay, so here we have. Just a moment. So that is the polynomial. So this is the polynomial. In short, 1D to 2D convert kiya. This is actually RBF. RBF in the sense radial base. Radial base in the sense, consider you have a cluster type of data set. I consider here I have actually two class levels, red and green, but it's a cluster type of things. Okay, I cannot actually draw a polynomial. Otherwise, polynomial in the sense this is the polynomial. Okay, 1 minute. Where is the diagram? Yeah, fine. This is the polynomial. So polynomial in the sense I do not want to draw a straight line. I want to draw a curved shaped line. Okay, मुझे curve shaped line draw करना है. That's actually polynomial. And what about the actually RBF? RBF is another kernel function which is just used to divide the whole thing into small circles. Okay, not whole thing, but it just divide. It just like draw a circle on a cluster specified on that feature value. So that's actually radial based kernel. So it depends. We will not discuss that. We will just discuss this polynomial kernel. But that is also the concept. This is also the function. And if you have a data set which is actually divided into small clusters, and you want to just draw the circles on that cluster, what we can do? This is actually a kernel function. Like this is the kernel function for our polynomial. What about this d? D depends on dimension. If you are working in 2-dimensional, you have to just put the value of d, that's 2. 3-dimensional, then 3. 4-dimensional, then 4. We will just learn that. We will just learn about this constant value that is actually known as SVM parameter tuning. In next session, we will just discuss that thing, but I hope this is clear. So these are the polynomial, sorry, these are nothing but in kernel functions, polynomial kernel, radial basis kernel, or hyperbolic tangent kernel. So that is also the function, that is actually a function for hyperbolic tangent kernel. So now fine, so these are the kernel we have to apply to just make our non-linear separable space into linear separable space. Okay, so that's that. Now another thing is, if you still want to know something more, I have actually 2 PDF. I will just share this PDF with you guys. So here in this they just give some examples. So this is the function, we know this function actually, and actually they explain each and everything in detail with some actually examples also. Maybe in this PDF there is an example. Just a moment, let I just scroll down. Yeah, fine. So in this PDF there is an example. So consider I have a data points. I have only 2 data points actually. X1 and X2 are the feature values, and X and Z are 2 data points, and these are the feature values actually. So now what is my requirement? I want to just apply K. In short, that's a kernel space. So what we applied actually, XZ square, that means X1 Z1 plus X2 Z2 whole square. Okay, now what about that T? T in the sense I want to just make a transpose of them. Okay, the X1 X2 and Z1 Z2, that means I mean to say like X1 X2, and otherwise you can just guys note down X1 X2, that is the first value, and here Z1 Z2. Okay, so अब इनका मैट्रिक्स मतलब मल्टीप्लिकेशन करना है, तो x1 का z1 के साथ मल्टीप्लिकेशन होगा प्लस x2 का z2 के साथ होगा. अब मैट्रिक्स मल्टीप्लिकेशन अप्लाई करें, first row first column and something like that, x1 z1 plus x2 z2. So right now this t stands for transpose, and z that will be considered as x1 z1 plus x2 z2 square. Now अगर आप अपना फॉर्मूला अप्लाई करें, then x1 square z1 square plus x2 square z2 square plus 2 x1 z1 x2 z2. Now इसकी जगह हम कुछ इस तरीके से लिख सकते हैं, x1 square comma under root of 2 x1 x2 x2 square transpose. In short अब जब आप इनका multiplication करेंगे guys, then you will get this value. What about this one? That's actually phi xt and phi xz. So this is a kernel function which we choose, and that is equivalent to inner product of that phi function. So what's that phi function? That's actually you can just derive that from here. So that's the phi function, x1 square under root of 2 x1 x2 x2 square. जैसे हमारे पास दो फीचर वैल्यू थी तो हम लोग ये फंक्शन पे जाएंगे. So phi function अभी हमने देखा, but how to find out that? तो अब ऊपर के theorems थोड़े से read करोगे, you will get the answer actually. How to choose the phi function, we already discussed that, but that's not an important thing. But still I have this thesis value, otherwise this actually PDF value जहाँ से आपको पूरा का पूरा phi function मिल जाएगा. Fine, this is also another one जहाँ पे actually primal to dual forms, linear separable, revisited, revised actually feature map. So this is the feature map जहाँ पे आपको phi मिल जाएगा. Kernel of SVMs and regression value. Regression still हम लोगों ने learn नहीं किया, but kernel of SVM and etc. I think you will get guys. Okay, so ये भी एक अच्छे से पूरा का पूरा समझा रखा है, like C equals to 10 in the sense soft margin. यहाँ पे soft margin समझा रखा है. Okay, तो जितना C का value smaller उतना actually आपको compromise ज़्यादा करना पड़ेगा. So like that, this is actually soft margin, and that is actually known as slack variable. So this is the original symbol of the slack variable. That is actually slack variable. And what about this linear classifier not appropriate? जैसे ये, it's not classified value. So we can just classify by using actually drawing by just applying theta and r. In circle draw का हम लोग काम कर सकते हैं, but it is hard to draw the circle. So what we can do, we can just transfer this data set into a 3D data set. So this is 3-dimensional data set. ये 2D को 3D में define किया, हम लोगों ने इसको visualize भी किया हुआ है. And finally we can just apply like SVM, because right now it is linearly classified data. So that's that. So now apply करने के लिए phi x1 x2, that will be considered as x1 square x2 square under root of 2 x1 x2. So r square in the sense 2-dimensional data is right now considered as 3-dimensional data set. So finally वो 3-dimensional में divide होने के बाद easily we can just introduce a hyperplane to divide or to separate these two, and that hyperplane is nothing but an SVM. And guys, we know actually अगर हमारे पास 2-dimensional data है, then SVM is nothing but an 1-dimensional line. And if we have 3-dimensional data, then we will have actually hyperplane of 2-dimensional to separate data space. In short, if you have n-dimensional data, then n-1 dimensional will be SVM. Okay, SVM dimensional will be n-1. That's that. So that's that. That is something about the SVM non-linear data set. Now what we will learn in next session, we will learn actually SVM tuning parameters. In short, in this slide we have something like let I just open this once again. 1 minute. Yeah, fine. So here in this finally we just got the kernel trick, and in this kernel trick right now we have something, and that something is actually D. That's the constant. We have actually this sigma, that is the constant, and we have actually delta and kappa constants. So how to fetch the value of this? So that's actually known as SVM parameter tuning. So we will just learn that thing in next session, and finally we will just start programming. So that's